Hello and welcome class. So in last class I have taught about introduction of the motion. In today's class we will actually going to start the chapter motion from the topic describing motion. Clear class? In last class we have mainly discussed about frame, rest and motion. So let's begin today's class. We describe the location of an object specifying our reference point. Whenever you have to start describing some distance, some weight, okay, we took first thing as a reference point. For example, you have seen the old style weighing machine. Okay, how you weigh your vegetables on these type of weighing machine. If you want to purchase 1 kg of vegetable, okay, what you will do? You will put a 1 kg block on the other side to balance this scale, okay. So this 1 kg is our reference. 1 kg block is our reference. We are taking that 1 kg block as the reference and trying to describe the weight of vegetable using that 1 kg block. Similarly, if you want to describe the length of any object, okay, you always need a reference point. For example, in a class, you have 3 friends sitting in 3 different positions, and fourth friend is sitting here. Friend A is saying that friend D is sitting away from me around 2 meters. Friend C is saying that she or friend D is sitting away from he or she 5 meters. And friend B is saying that D is sitting 3 meters away. So all these distance is calculated using different frame. According to A, D is 2 meters away. So this is according to A. According to C, D is 5 meters away. And according to B, D is 3 meters away. So all three are not wrong. Okay. According to them. So I am using a word according, and in physics language that according become reference point. And let's understand this by an example of a railway station and a school. Let assume that a school in a village is 2 kilometers north of a railway station. This is a railway station, okay, and a school is 2 kilometers away. So how we are measuring the distance of the school? We are first taking railway station as our reference point, that we will start calculating the distance of the school from the station. So station is our reference point. Reference point. Okay. So you are measuring the distance of school from the station. So station will become our reference point. If any other person come and say that the school is 5 kilometers away from a factory, so that person is taking factory as his reference point. Okay. So for person A, station is the reference point. For person B, factory is the reference point. Clear class? So we will choose first thing from we will first choose reference point. After that, we will start calculating all the thing, distance, time, everything from a reference point. And in maths, reference point is known as origin. If you are calculating the distance between school and the station, you have first assumed that station is at 0, and then you have start calculating the distance that school will be 2 kilometers away from the station. So you have choose station as the origin in the scale. When you see your centimeter scale, you will first start measuring anything from the 0. So 0 is the origin. In this example, railway station is the reference point. We could have also chosen other reference point, for example, that factory, according to our convenience. Okay. Therefore, to describe a position of an object, we need to specify reference point called the origin. Reference point is called the origin because we have taken the distance of the reference point as 0. Clear, class? So we now understand the definition of reference point and origin. Now we start our chapter, motion along a straight line. So motion in a straight line or motion along a straight line is the simplest type of motion, because we will mostly say that a particle is moving in a straight line, calculate the distance. Okay, straight line is very easy. Other motion like zigzag motion or circular motion or spiral motion, different type of motions are there. Those are little difficult. The simplest type is the motion along a straight line. Now let's understand the motion along a straight line through an example. Okay. The example is this. Suppose origin is your home. You and your father is driving. Okay. Your home is the origin. So we have taken origin as 0, or your home is in 0 position. You and your father decided to drive the car. Okay. So your father is driving, you are sitting in the car, and you are moving in a straight line, and you have covered 60 kilometers distance. 60-kilometer distance. Okay. Now your father take a U-turn and start returning back to the home. Okay. You first reaches this B point, which is the 35 kilometer from the 0, and your father stop at C point, which is 25 kilometer away from home. Clear, class? So this is a condition. Origin is our home. You and your father is sitting in a car. Your father is driving, and you are just moving along a straight line, and the distance from home to the point you reached is 60 kilometer. You spend some time there, and then you return back in same path and reaches C point, which is 25 kilometer away from home or the origin. And in between you reached a B point, which is 35 kilometer away from your home. This is the diagram. Now we will discuss this problem truly. Let ABC represent the position of the object at different instant. ABC are the three position at different time. At first, the object moves through C and B and reaches A. Okay. From O, you first reach the C point, then B point, then A point. 60 kilometer is the A point, C point is 25 kilometer, and B point is 35 kilometer. Clear, class? 5. Then it moves backward along the same path and reaches C through B. So first you reach A, and then you move back and reach C point. So if I ask you how much distance you covered, if this is 0, C point is 25 and A point is 60, how much distance you have covered. Total distance you traveled is, you first travel from O to C. O to C A O to A. O to A is 60 kilometers. Then you return back and reaches C point. So how much distance it will be? C is 25 kilometer away from home. So this is 25. The total is 60. So this much distance will be 60 minus 25, which is 35 kilometers. So AC is 35 kilometers, and total distance you traveled from O to A to C will be, total distance you traveled is OA plus AC, which is 60 plus 35 equals to 95 kilometers. So total distance you traveled is 95 kilometers. So from here, a new topic arises, which is total distance or distance. What is distance? And distance is defined as the total path length covered by the object. Clear, class? So this is the definition of distance. Total path covered by the object. For example, in this case, you have first traveled from 0 to A, you have traveled 60 kilometers. When you return back, you have traveled 35 kilometers. What will be the total path covered by you? The total path covered by you will be the 0 to A plus A to C, which is 60 plus 35, 95 kilometers. So the definition of distance is total path length covered by the object. Is it clear, class? Okay. Total path covered by the object is called the distance. To describe the distance, we need some numerical value, but we does not need a direction. For example, you have first go from O to A north 5 kilometers. Then you walked away in west direction 10 kilometer. Then you move back to south 2 kilometer. Then you move again to the west direction 4 kilometer. Okay, how much distance you have traveled? So remember, distance is independent of direction. So how much distance you traveled? 5 kilometer plus 10 kilometers plus 2 kilometer plus 4 kilometer. 31 kilometer. You have traveled 31 kilometer. Clear, class? So distance is independent of direction, but it is described by this numerical value, 31 kilometers. Kilometer is unit and 31 is a numerical value, and in physics numerical value are called as magnitude. Okay? So distance depends on the magnitude and unit and independent of direction. Distance depends on magnitude, unit, but independent of direction. Okay. So distance depends on magnitude and unit but independent of direction, and this example explain you all of that. This 31 is magnitude, kilometers is the unit because distance can be measured in different unit, kilometer, meter, centimeter. Okay. So depends on magnitude, depends on unit but independent of direction. It is just the total path traveled by the object. Clear, class? There are certain quantity which are described by specifying only the numerical value. Like distance, there are more quantities which only depends on the numerical value and independent of direction, and numerical value is its magnitude. What numerical value are called? It is called as magnitude. And I have explained you that distance has many units. Distance has many units. For example, we can measure distance in kilometer, we can measure distance in meter, we can measure distance in centimeter. There are other units: inch, foot, miles, etc. So these are the unit of distance, but in physics language, we will choose meter. This is the standard unit of distance, also known as SI unit. So the SI unit of distance is meter. So we will do all the calculations in meter. Okay. So the standard unit of distance is meter, but distance got many units: kilometer, meter, centimeter, inch, foot, okay, miles. You should know the relationship between kilometer to meter, meter to centimeter. So we know that 1 meter is equal to 100 centimeter and 1 kilometer is equal to, kilo means 1000 meter. So this is the relation between meter to centimeter, kilometer to meter. Clear, class? Is it clear to us? Now let's return back to our previous example. What was that example? That you and your father is in a car and your father is driving the car. You have begun from home, which is our origin, A point. Then you reaches point A, passing through 2 points C and B. Then you return back to the C point. So we have calculated total distance. Okay, C was 25 kilometer, B 35 kilometer, and A was 60 kilometers. And we have calculated total distance or the total path traveled by you is 95 kilometers. Okay. So O is your initial point. Okay, the point from which you begin in physics language is called as initial point. Initial point. And you ended up reaching C point. So C is your final point. What is C? C is final point. So you begin from A. So A is your initial point. You end it on C. So C is the final point. If I ask you how much you displaced, how much you displaced? You was on O, ended up in C, and the distance between O and C is 25 kilometers. So O is your initial position or initial point. Initial position, and C is your final position. Final position. If I ask you one question that how much did you displaced, what will be your answer? Okay, it is clear to us that you first go from 0 to A, then you return back to C. But if I ask you how much you have displaced from your initial position, or how much your position shifted, then your answer will be 25 kilometers, because you are at C position. Originally, you was on 0 position. And the distance between 0 and C is 25 kilometers. Okay. So your shift, or you have displaced 25 kilometers. Is it clear, class? So you have displaced or shifted 25 kilometers. Now a term arises which is known as displacement, and displacement is the shortest distance measured from the initial to the final position of the object. This is your initial position and this is your final position. Whenever you will draw a straight line between initial and final position, this will give you displacement, that this much you have displaced from your original position. Okay, and the shortest distance is always a straight line. Shortest distance is always a straight line, and straight line require 2 points. And those 2 points are initial position and final position. So you have initial position, you have final position, draw a straight line. That straight line will be the shortest distance between initial and final position, and that distance is called as displacement, known as displacement. Clear, class? So this is the definition of displacement. I hope displacement is clear to you. Now let's take another example. Suppose you are doing jogging on a circular path. You began from here and you ended up here. This was your initial position, and you have covered the half distance of the circular path. Okay, you jogged here. Now you finally reaches this position, which is your final position, and you learned that this final position is diameter of this circle, and let's assume the diameter of circle is 14 centimeter. What will be the circumference of this half part? The circumference of this half part will be pi r. Pi is 22 by 7. And what is radius? 7. So you have moved 22 centimeter. So 22 centimeter. Now can you tell me from this example what is your distance covered and what is your displacement? So your distance will be 22 centimeter. And what will be your displacement? So the distance between initial point and final point after drawing a straight line is 14 centimeter. You haven't traveled on the diameter, but displacement did not ask about it. Okay? Distance is the path traveled by the object. Displacement is the shortest distance, which is the distance of the straight line between initial and final position. Okay, so the displacement will be 14 centimeter and distance will be 22 centimeter. So from this example, I hope you have learned about what is distance and displacement. In today's class, we have learned about what is reference frame, origin, what is distance, displacement, initial point, and final point. In next class, we will begin from studying about distance and displacement, and we will still continue that example of the car travel. I hope this class is clear to you. Thank you.